All right, we're going to talk about adding linear expressions. Adding linear expressions is going to look a lot like combining like terms and simplifying expressions because it pretty much is, except that they're going to keep two expressions separate and have us add them together. So, first of all, let's just talk about what this word linear means. So I touched on it a few days ago. There is a difference between just linear expressions and algebraic expressions in general. A linear expression has variables that have an exponent of 1. So we're not going to see any x squared, x cubed, x to the fourth. It's just x's, y's, any variable, but at the exponent of 1, which we know if the variable doesn't have an exponent, it's a 1. So examples of linear expressions would be any of these because you'll see the variables don't have an exponent on it, which really means its exponent is 1. And then nonlinear expressions would have that variable on there. So it disqualifies it from being linear anytime it has an exponent that's not a 1. And your book just covers linear expressions. So that's what we're going to be talking about. So we're going to add linear expressions. So they're going to take two expressions, they're going to put them in parentheses to show you that they're two separate expressions, and they're going to ask you to add them. So to do that, it says you can use a vertical method, which I don't love. Why is this so tiny? Let's make this bigger. But I'm going to show you how to do it anyway. So if we're adding x minus 3 and 4x plus 6, we can write them vertically, lining up like here are the constants. We're going to line them up. And then here are the x terms and line them up. And then negative 3 plus 6 is 3. 1x plus 4x is 5x. And this would be the answer. I prefer doing it horizontally. It's much more like much more like simplifying expressions and just combining like terms. So if we have this example, negative 5y plus 2, and then we're adding that to 13y minus 7, you can actually write them without the parentheses because we're just adding these things together. And then you can go ahead and do it the way we did notes last time, where we're going to circle our like terms. Here are the y terms. Remember, again, I know you're sick of hearing it, that we're going to include the symbol in front of each term so that we know when they're positive or negative. And then I have a 2 and a negative 7 to make negative 5, and this would be the answer. So I kind of think that way is easier. So let's do it that way down below here. I'm going to rewrite this just as x plus 3 plus 2x minus 1. I'm going to combine like terms. So first let me identify those like terms. I have an x and a 2x. And then I have a 3 and a negative 1. So my answer is going to be x plus 2x is 3x. 3 minus 1 is 2. And that's the most simplified I can get it. I know it's simplified because there are no like terms and no parentheses. So I know it's in the most simplest form. This next one says 4 minus n, and then we're adding 2 times this expression, negative 5n plus 3. So I'm going to have to use the distributive property. So I'm going to do 4 minus n, and then I'm going to do 2 times negative 5n, and 2 times 3. So I'm going to write that again, but I'm going to actually multiply 2 times negative 5n would give me negative 10n, and 2 times 3 is 6. Now I'm going to go through and show my like terms. I have a 4 and a 6, and then I have 2 n terms, a negative 1n and a negative 10n. My answer will be what I get when I combine my like terms. So first I'm going to put the n term down because we like to have the variable terms first and the constant last. So negative 1n and negative 10n makes negative 11n, and then 4 plus 6 is 10. And that's my simplified expression. The last one has two distributing parts before I can go on here. So I have 1/2 times 4r and 1/2 times 6. And I'm going to add that to 1/4 times 20 and 1/4 times negative 8r. So let's see if I can fit all this on here. So actually, I don't even think I need to write it out because everyone gets afraid of fractions, but really 1/2 times something is just taking half of that number. So you should be able to do half of 4 in your head. So half of 4r would be 2r and half of 6 is 3. Same thing with 1/4. If you do 1/4 of something, you're dividing it by 4, just like 1/2 of something was dividing it by 2. So 1/4 of 20 is 5 because there are 4 5s in 20. So, or 20 divided by 4 is 5. And then if you're doing 1/4 of negative 8, that's like dividing it by 4. So negative 8 divided by 4 is negative 2. So 1/4 of 8r is negative 2r. Now I'm going to go through and identify my like terms. I have a positive 2r and a negative 2r. And then I have a 3 and a 5. We're going to do our r term first. 2r minus 2r is 0. I don't have to write 0r. I'm not going to write down 0 of something. There's also 0 x's in this expression, but I'm not going to write 0x. So these like cancel each other out, and all I have is 8. So it's possible to have an answer that just has one term. All right, lastly here, we're going to do a word problem. You earn 6x plus 5 points after completing x levels of a video game and then lose 8x minus 3 points. Then you lose them. This one is subtraction. So, oops, which is what we're learning in the next set of notes. So I'm going to hang on to this word problem and do it with our next video when we talk about subtracting expressions. So this is it for adding expressions. Thanks for watching.